So here's a slide I called "There's a Winter What Issued?" So we have a lot of products in the Weather Service that we'll put out trying to alert our customers, you guys, and everyone else about what kind of weather we're expecting to happen. So I kind of have a little graphic here. On the left-hand side is what we call watch products. So this means that conditions are favorable for severe weather in the watch area, and that's oftentimes issued beforehand, 2-3 days before we think an event's going to happen, sometimes maybe a day before. And then from that point, we have to make a decision whether to go to a warning or an advisory. So a warning is severe weather occurring or about to occur. And then advisory is still something we want to let you guys know about, but it's less impactful. We think it's going to be more typical. So that's non-severe or nuisance weather occurring or about to occur. So you'll oftentimes see, winter storm watch or winter storm warning or maybe winter weather advisory. So this can help kind of just put them in these broad categories of what to expect. So on this next slide here, I just kind of put in blue letters maybe another way of thinking of it instead of thinking of the watch, warning, advisory, because that can sometimes get confusing. Early heads up is a watch. A warning is a big storm or high impact expected. And then an advisory is a typical storm or a moderate impact expected. So hopefully that helps kind of put into context the different types of products that you see issued by the Weather Service. All right, so now we're switching pace a little bit here. Just a quick winter outlook. So this applies to December, January, February, and this is current as of end of October. They'll come out. These graphics are issued by the Climate Prediction Center, which is a branch of the Weather Service, and they kind of look in the look out further than what we do. We focus on the first 7 days, and they're kind of looking. They look at the first 10 days, but then they also go out and do seasonal outlooks. So this year, the best chance is for a weak La Nina, and what La Nina means for the United States is kind of depicted in these two graphics. So the one on the left shows areas that have a better chance of being wet than dry, or vice versa, and then the right graphic is showing temperatures, so a better chance of being either hotter or colder than what a normal winter would produce. So on the left, I kind of circled Montana. So you can see for western and central Montana that La Ninas often produce wetter than average conditions. This doesn't mean that there's going to be snow every day or rain every day. This just means when we look back on the whole season, we're predicting that we'll probably get more precipitation than what is normal. On the right-hand side, the temperature graphic, you can see that central and western Montana are kind of in the equal chance. So just because there's a La Nina, we can't really say one way or another what we're going to get for temperatures. So there's going to be cold spells and warmer than average spells, but there's not an overall trend as far as what we can tell ahead of time based on La Nina. So this kind of gets into it's a detailed graphic here, but the blue lines are showing each day's high and low temperature, and that brown range you see in the middle is the average high and average low temperature for different days of the year, starting in the beginning of September and going to the end of November. So I just show you this graphic. The details aren't important, but just to say that weather is different from climate. So we're kind of looking at a seasonal climate. When we look at the winter outlook for La Nina, we're looking at a seasonal, like kind of the average over the whole winter. So that's much different than the day-to-day. Just because we're going to be wetter than or predicted to be wetter than average this winter, that doesn't mean we're going to have, tons of snowpack or something like that, or big storms that cause lots of snow accumulation. It means that over the course of the winter, we're thinking they'll be above average precip when we add it all up. All right, so now we're going to switch and talk about some specific winter weather hazards that we'd like you guys to look out for, and again, give us a call if you see any of these. So freezing rain, that's a big one for us. The definition is any accumulation of liquid water on frozen surfaces. Any amount of freezing rain can be dangerous, so please call and let us know anytime you see that. The graphic here shows an example where there is a lot of freezing rain causing quarter to a half inch amounts, But even when you have just trace amounts, enough to coat a surface or even start coating a surface, that can cause cars to lose traction, and we quickly end up in situations where we have tens, if not hundreds of cars off the road and big dangerous situations developing. So anytime you guys have something like that happening where you are, please call and let us know so that we can adjust our messaging and let others know that there is dangerous weather occurring. Here's a graphic that I believe a fellow National Weather Service office tweeted out not too long ago, just a few days ago. But I thought this was a great summary. So it kind of highlights the different types of winter precipitation. So on the left-hand side of the graphic, you guys are very familiar with what snow is. Just about everyone knows what snow is. Everyone knows what rain is. The middle ones are sometimes more confusing about how those form. So just starting on the right-hand side, rain, you can have snow falling even in the winter, have snow falling, or I should say even in the summer or spring, fall transition seasons. You can have snow falling at high elevation in the cold air up in the upper atmosphere, but then it passes through warm air and melts, so then you get rain at the surface. On the far left, you see snow. That's when the whole atmosphere is below freezing cold. You just get our ice crystals that we're used to as snow. The middle two are, they really depend on a warm air layer and how thick the warm air is versus how thick the cold air is at the surface. So in a freezing rain scenario, the second from the right, you can start off with snow, but it melts, turns into rain droplets, and especially if the surface is below freezing, it can fall through some cold air, but it's not cold enough to freeze the droplet until it hits the surface. So that's when you get that dangerous freezing rain we were just talking about. Sleet or ice pellets happens when there's just a thin warm air layer, and snow is able to melt but then refreezes, and it's more balls of ice that are hitting. So that's how you get sleet. So I thought this graphic did a great example, or was a great way of depicting kind of how these different types of precipitation form. So this isn't necessarily important when you're calling in. Just let us know what you're seeing, but for your information, this is how those are formed. All right, another thing we look for is sudden changes. So snow banding is a great example for us here in western Montana, at least, where we can oftentimes have snow showers that are coming off of the mountains and kind of lining up in certain areas. So they can be very localized and can produce inches of snow over a short period of time. This image right here shows that there's some heavy snow falling in the distance, but where the viewer is, the ground is dry. So these changing conditions can be very dangerous for travelers who are going 80 miles an hour here in Montana, and then all of a sudden the road changes from dry and 80 is a fine speed to go down to 15, 20 miles per hour might be a safer amount if the road is snow covered. So please let us know anytime you see these sudden changes in visibility and precipitation. Early and late season snow. So now that it's November, we're kind of out of this season, but anytime the trees have leaves on them, whether that be before they fall off or when they've already budded, we can get a lot of damage from snow. So when we get into those shoulder seasons, please give us a call if you're getting snow, even if it's just light amounts, because that's something that can quickly turn to a hazardous situation. And here's a slide we put in. Even 1 inch of snow can be a big deal, so that kind of goes hand in hand with what we were just talking about. But some other details we look for are intensity of snow. Is it just flurries, or are there whiteout conditions? Flurries are going to be, just a nuisance if that, but whiteout conditions and heavy snow can be a big problem for travelers, for airports. Another one, call whenever snow starts or ends, so we already mentioned that, but giving us an exact or approximate time helps us see. We can look back and look on radar, see what kind of shower it was, and then we know what to expect for the rest of the evening or day when we know what kind of snow shower went over you based on when you said the snow started and ended falling. And we are still learning. So years ago, our focus was on larger snow events, and we might not have wanted you to call in for 1 inch of snow. But now if you find a situation odd, interesting, or impactful, please do call us and let us know, because that's very helpful for us to know what's going on out there. And we love hearing from you guys. You guys are among the best educated of people in our area for weather. And when we get your reports, that means it means a lot to us, and we know that we can trust based on what you're giving us. So I think, oh yeah, okay, so one more slide here before I turn it over. Just some snow measuring tips. So if you guys want to call in a snow total that you got either overnight or it's just coming down really fast, find a flat area where snow does not tend to drift or blow away completely. So non-windy areas are best. Take 3 separate measurements and take the average. So just sticking in one place can sometimes throw off the measurement. So if you can ideally just stick the ruler in 3 different places, that's a great way to get a more accurate measurement. And then try and take them in the same area, so that when we oftentimes get to know you guys based on, you'll call in often, and that's great. And then if you're taking in the same area, we can know that we're comparing apples to apples. All right, so let's see. Yeah, so with that, I'm going to pass it off to Keith from NWS Great Falls, and he's going to take over for the center part of the presentation, and then I'll wrap up at the end with a couple more slides too. So without further ado, I'll pass it off to Keith. All right,
Thank
Keith.
you very much, Lance. Hopefully everyone can see the blizzards slide in front of them right now. But what is exactly a blizzard? Are you able to hear me well?
Yep, I can hear you, Keith, and I can see your blizzard slide.
All right, excellent. So, of course, as we all know, a blizzard, it's dangerous and life-threatening, but more specifically, it has sustained wind or frequent gusts of at least 35 miles per hour, as well as visibility less than a quarter mile due to considerable blowing and or falling snow. And it's important to note that those conditions must prevail for at least 3 consecutive hours in order for this sort of weather event to be a true blizzard. Now, as we all know, Montana is known for being a very windy state, and that's especially the case east of the Continental Divide. This map shows average winter wind speeds across Montana. Notice that the white represents where those average wind speeds are highest, so we happen to find those just east of the Continental Divide in western portions of Glacier as well as Pend Oreille counties here in north central Montana. And these highest average winter wind speeds are in part due to downslope winds. And I'll go over downslope winds in greater detail momentarily. First of all, though, the highest recorded wind gust here in Montana was actually 143 miles per hour. And this is out of wind gusts that are not the result of tornadoes or severe thunderstorms. So this wind gust was actually the equivalent of a Category 4 hurricane wind gust, and it occurred back on February 21st, 2002 at the Miller Colony, which is on the plains of north central Montana, not far from Choteau. The highest average annual wind speed in Montana is nearly 18 miles per hour, and that's along Logan Pass in Glacier Park, while the lowest average annual wind speed is approximately 2 miles per hour, and that's in Condon, which is in western Montana. Now, west of the Continental Divide here in Montana, the winds are typically terrain-driven. In other words, the winds tend to blow up valleys as well as mountains during the day, and then at night, winds tend to blow down those valleys as well as mountains. Now, here east of the Continental Divide, including Great Falls, our winds are typically out of the west or southwest, and that is due in part due to the typical storm track that's followed by large-scale storm systems that impact our state. Now, as I mentioned before, downslope winds are an important phenomenon east of the Continental Divide, especially here in Montana. And in our state, we call these Chinook winds. So as these downslope winds blow from higher elevations to lower elevations, that sinking air warms and dries by compression under the increasing weight of overlying air, and it also accelerates due to gravity. So as a result, these downslope winds can be and often are quite strong. Now, as air flows over a mountain range, it tends to behave like a wave as it moves up and down several or more times, not only over the mountain range, but downwind of the mountain range as well. And this wavy airflow is what we meteorologists call a mountain wave. Now, the mountain wave will rise just beyond the mountain range as well. And where that air rises, it often expands, cools, and condenses into a large and extensive band of cloud cover that we call a Chinook arch. And the Chinook arch often occurs here in north central Montana, especially in fall, winter, and spring. And it also often occurs just east of the Rockies up in Alberta as well. Now, as shown in this picture, a Chinook arch typically has what we call a laminar or smooth appearance to it. And also a defining characteristic of a Chinook arch is a distinct or sharp western edge that happens to face the mountain range. So if you happen to see a Chinook arch as a spotter, you know that there is turbulent or wavy airflow occurring over and downstream of the mountain range. Another important phenomenon is upslope precipitation. This occurs when moist air encounters a mountain range and is forced to rise along the windward or upwind side of those mountains. And as the moist air rises, it expands, cools, and condenses into clouds, which may then produce precipitation. So putting it all together, upslope precipitation occurs along the windward or upwind side of the mountains, and it may result in significant amounts of rain or snow, while downslope flow occurs along the leeward or downwind side of the mountain range. And as mentioned before, this downslope flow typically results in mild, dry, as well as windy conditions. And it's important to note that this situation can cause motorists to encounter rapid changes in weather and road conditions while traveling over a mountain pass, such as Marias Pass up near Glacier National Park or McDonald Pass west of Helena. Switching gears a little bit, it's important to talk about ice jams here in Montana, and that's because Montana actually has the highest number of reported ice jams and, unfortunately, ice jam-related fatalities here in the lower 48 states. Now, east of the Continental Divide, ice jams here in Montana are most common during the months of January, February, and especially March, while west of the Continental Divide, ice jams are most common during the months of December, January, and especially February. There are two types of ice jams. The first type is called the freeze-up jam. This occurs when prolonged cold weather allows an ice cover to develop on a river or stream, and this type of ice jam may produce minor flooding upstream. That, though, depends on the thickness of the ice cover and whether or not the ice cover actually blocks some of the flowing water, causing it to back up and cause flooding upstream of the jam. The second type of ice jam is called a breakup jam. This occurs when prolonged cold weather is followed by significant warming, which allows the ice to break free and flow downstream. Then the chunks of ice accumulate at obstacles such as bends in rivers or along bridge supports. And when the chunks of ice accumulate in these areas, they may then refreeze in place to form a blockage, and obviously that blockage will cause flooding upstream. Now, these icy blockages, they're also highly unstable, and they may release suddenly, and when that happens, flash flooding occurs downstream. So between the two types of ice jams, the breakup jams are typically the more significant type. Here are some important dangers associated with ice jams. As ice jams form, water from the river can get pushed around the edges of the ice, which leads to flooding of low-lying areas along the river. And as chunks of ice flow down the river, they can get pushed ashore by the water, causing damage to homes, bridges, roads, and other things along the river. Switching gears a little bit again, there are three types of cold air masses that affect us here in Montana. The first type is called a continental Arctic air mass. This consists of frigid air temperatures as well as very dry air. These air masses originate north of the Arctic Circle, and they're preceded by what we call an Arctic front, which happens to be the leading edge or front of that very cold, dry air. The second type is a continental polar air mass. This consists of cold and dry air. However, the cold air is not as cold as that associated with an Arctic air mass. Continental polar air masses in our neck of the woods originate over Canada as well as Siberia, and they're preceded by what we call a polar front. And lastly, the third type of cold air mass is a maritime polar air mass. This consists of cool and moist air. For the maritime polar air masses that impact us here in Montana, they originate over the northern Pacific Ocean, and they're preceded by what we call a Pacific front, go figure. But this is also sometimes referred to as a cool front because, again, the air behind the front isn't particularly cold. Now, when it comes to maritime polar air masses, they're typically accompanied by clouds and precipitation, especially west of the Continental Divide here in Montana, while east of the Continental Divide, these air masses are accompanied by windy, dry, and cloudy conditions. In other words, these air masses are somewhat modified by those Chinook or downslope winds that I had talked about a few minutes ago. And it's also important to keep in mind that with Arctic fronts as well as polar fronts and Pacific fronts, they're all capable of producing narrow bands of intense precipitation which may fall as snow, of course, especially this time of year and as we go into the winter season. And as Lance mentioned earlier, these narrow, intense bands of snow can cause rapid changes in weather as well as road conditions. In some instances, visibility, for example, can change from nearly unlimited to near zero within a matter of only a minute or even seconds. So definitely, that's something important to keep in mind while traveling across our state this time of year and during the upcoming winter. Now, talking about Arctic air masses in a little bit more detail, of course, as we all know, we sometimes experience extreme changes in temperatures, and these can occur very rapidly here in Montana. For example, those Chinook winds can erode an Arctic air mass, causing the air temperature to rise from well below zero to well above 0 degrees Fahrenheit within only an hour, or even in some instances just a few minutes. Now, Arctic air, it's very dense, and as a result it easily hugs the surface, causing the layer of frigid air to actually be quite shallow. And as mentioned before, these Arctic air masses are typically preceded by a strong cold front that not only brings precipitation but also high winds. Now, the chart to the right actually shows the coldest recorded low temperatures for multiple locations in western Montana as well as north central and southwest Montana. Here in Great Falls, our coldest ever low temperature was actually -49 degrees. That occurred on February 15th of 1936. And in Missoula, their coldest ever low temperature was 33 degrees below zero, which occurred back on January 26th of 1957. Now, something that you often hear about is the wind chill. If you don't know, this happens to be the temperature that it feels like outside based on the rate of heat loss from exposed skin due to a combination of wind and cold. In other words, during cold and windy conditions, the wind will blow some of your body heat away from any exposed skin. That in turn causes your skin temperature to decrease, and as a result, it ends up feeling colder than it actually is outside. Now, to the right is the official wind chill chart from the Weather Service. And it's important to note that wind chill is only defined for temperatures that are 50 degrees Fahrenheit or colder and accompanied by wind speeds of at least 3 miles per hour. And this wind chill chart assumes that there is no sunlight, which would otherwise warm your skin temperature a little bit. So if you take a look at the wind chill chart, you'll notice that if we have a temperature of 0 degrees Fahrenheit and it's accompanied by a wind speed of 15 miles per hour, the resulting wind chill will actually be negative 19 degrees Fahrenheit. And under these conditions, any exposed skin will develop frostbite within only 30 minutes. So it's very important during cold and windy conditions to really bundle up, dress in layers, and do a good job minimizing any exposed skin. A product that we issue here at the office in Great Falls is called the Cold Air Advisory for Newborn Livestock, or CAN-L for short. This was actually originally developed by the Forecast Office in Glasgow, Montana, and it's an index that relates temperature, more specifically wind chill temperature, precipitation, as well as humidity. And the purpose of this cold air advisory for newborn livestock is to help ranchers minimize losses from newborn livestock happening to be killed by hazardous weather conditions. Now, on our website, the CAN-L is available at that link, although also if you navigate to our website, on our home page at the left, you'll find a link titled Items of Interest. If you click on that, you can then click on a link that will take you to this product. And note that when the Cold Air Advisory for Newborn Livestock product highlights extreme conditions, these conditions occur when the wind chill is negative 18 degrees Fahrenheit or colder for 2 or more hours, or the wind chill is less than 32 degrees for at least 2 hours, and during that time period, at least 1/10 of an inch of precipitation has fallen. Lastly, I'll briefly talk about avalanches. Of course, an avalanche is a mass of snow and ice rapidly moving down a mountain. Believe it or not, Bridger Bowl and Big Sky ski resorts near Bozeman are actually the second and fourth most avalanche-prone ski areas in the entire United States. But of course, mountainous terrain in the rest of Montana can also experience avalanches from time to time. If you're traveling in the backcountry during winter time or any time when there's a lot of snow cover, it's a great idea, of course, to travel with at least one other person. And also, we highly recommend you carry a GPS beacon as well as a shovel in case you find yourselves in a tough situation. And when traveling through well-known avalanche-prone terrain, it's a good idea to travel one at a time. In other words, travel single file in order to minimize the amount of snow that you displace. And obviously, when you minimize the amount of displaced snow, you're also minimizing the probability of an avalanche. So that's it for me. I'll now pass the presentation back over to Lance, and he'll talk about winter weather safety.
All right, I'm going to flip through these slides really quickly here. Forgot to move forward in the presentation. All right, so hopefully you guys, I see that's loading right now. Hopefully you guys see a slide that says winter weather safety. So thank you, Keith, for giving us the details on a lot of those different types of winter weather. And now we're just going to go over some safety reminders. All right, so for your family safety, winter travel safety kit. So a lot of you probably have these in your car, but we mentioned earlier in the presentation that 70% of winter storm-related fatalities occur in vehicles. So cell phone, almost everyone is going to be carrying that with them no matter what, but flashlight, some warm winter gear. If you're not already wearing that, that's important to have some of that in the car. First aid kit and blankets. So these are ones that people oftentimes think of, and they're all great and very essential. If I move forward here, you'll see some images of some often forgotten kit essentials. So when we have big blizzards, if a car goes off the road and you're stuck there for a while, having things like bottled water, even a shovel and sand or cat litter to kind of put under the tires to try and get off the, if it's not too cold, to try to get back on the road, a tow chain and rope, and then just some high energy food. These are things that can be really helpful, and a lot of times we don't travel with these, but they can help a ton if you do have them with you. So these are encouraged. So on this next slide, you'll see the Weather Service doesn't have an official app, but it's easy enough to bookmark our mobile.weather.gov page. The details of this, you have to do a couple steps. So the best way, if you're interested in having kind of a little icon to click on, it almost looks like an app on your phone. The easiest way would be to call one of our spotter lines, and we can kind of walk you through the process depending on which type of device you have. But this screen here shows a lot of different things that you can pull up. Almost everything from our official website can be pulled up on a smartphone or tablet, and you can look at that information. So it's in a condensed format that is smartphone friendly, and we encourage you guys, if you are interested, please do give us a call and we can help set that up for you. It's very convenient. I have it on my phone to easily check if I'm heading out somewhere. I can type in the zip code or even the city name of where I'm heading and get a quick forecast from the Weather Service. Another thing we want to continue to promote, most of you are probably aware of this, but if you're not, we in Missoula and Great Falls, and really across the whole Weather Service, we have Facebook accounts, Twitter accounts, and YouTube accounts where we post what upcoming weather we're expecting. So you can see the listings there. It's almost always based on the name of the office. And Facebook, we often use a couple, maybe a few posts per day on bigger weather things or bigger weather events that we're expecting upcoming, maybe a little bit further out in the future. Tweets we use for more, almost like a nowcast where events are occurring. We also use that for forecasting. We'll send out tweets, but you'll get those more often, many times a day. And then YouTube videos. Each office uses YouTube for a slightly different purpose, but we do fire weather briefings here in Missoula, and a lot of offices put out a weekly weather briefing that you can find on YouTube. So yeah, for anyone who's interested, the social media is a great way to get some more forecast information and in a less text-based or kind of in a way that's maybe a little bit more graphically appealing with some explanation from us just in plain English. So those are all sites we encourage you to visit. All right, so this is our last slide. Once again, it's a repeat of what you saw before, how you can help us report significant weather, start and end times, freezing rain, ice jams, any damages or impacts caused by weather. And we thank you guys for your time, and we look forward to your calls. The spotter lines below there are listed, so we'll keep it on the slide, and anyone who wants to write down those numbers, hopefully all of you can take those numbers down. So thank you very much for taking an hour out of your evening here, and I'll check to see if there's any more questions that came in and answer them live here. So let's see. Okay. So someone asked if it's possible to get a copy of the presentation. Are you still on, Keith? If you want to unmute yourself. I'm not sure which of these you answered already.
I'm here, Lance, and I happen to let Rhonda know that we can send the presentation to her, so I'll go ahead and email it once we're done here. And I see we also got a question about our website here in Great Falls, and if we can have the submit report button just like you guys in Missoula. I can definitely talk to our tech guru about that and see if we can add that feature to our website.
Okay, great. And does anyone else have questions? If you type in the chat box there, we'll hang out here we've got 20 minutes left in the hour, so if you guys have 20 minutes of questions, that would be amazing. But I think that's all we have officially, unless you have anything else you wanted to add, Keith. So anyone who is done can probably log out. Unless, was there anything else, Keith?
No, besides just thank you very much for joining us tonight. And we definitely appreciate your reports, as Lance mentioned earlier. You're definitely our eyes and ears out in the field. So thank you very much once again, and have a happy Thanksgiving.
All right, we got some good questions coming in. So it looks like, yep, Brian, we can send you a copy of the presentation as well. This is a good one. Would you rather we call with reports and then follow up with a report? So probably that submit report button. If you could call, that is the best, especially when it's, you know, a time-sensitive thing. If you're reporting when snow is starting, when it's ending, or I mean, really, we encourage getting your guys' calls. We're not a New York office. You know, neither one of us is a New York office where there's millions of people calling us. So if we have time, we're happy to take that call, and if we don't, we'll just let you know it's kind of busy. You know, something quick, or if you call us back, and then you can use the report button as well. But we are always happy to take your calls. How would we identify ourselves to you when we call? Is there something in particular you want us to say? You can mention that you're a spotter with us. We both maintain spotter databases, so we each have a list of people, but really just letting us know where you are and that you're a weather spotter. When you let us know that you're a weather spotter, that kind of increases how much we're going to trust your report, just because we know that you guys have had these training sessions. So let us know you're a spotter, where you are, and just what you're seeing. And we'll ask, oftentimes we'll just ask questions. You know, if someone calls in to report snow and we think there might be a chance of freezing rain, we'll just follow up with that and ask, you know, are you seeing any freezing rain as well, or how did it, you know, when did it start? So we'll kind of walk you through that stuff. I wouldn't worry too much about how to, other than just that you're a spotter and you have something to report to us. All right, to set up the smartphone widget, do we call the 1-800 number? So that's the only number. We do have public lines that you can call if you're on the bottom of our website, if you guys are familiar with that, weather.gov, and then you can click on your area and it'll pop up. On the bottom of our website we have public lines, but please go ahead and call that 1-800 number too if you're interested in getting that widget set up. If that goes to voicemail, just leave your number and that you're interested in getting that set up, and we'll get back in contact with you to help you set up the smartphone widget. All right, Jim would like to copy the presentation as well. That sounds great. We'll be sending those out. And then it looks like Renee also has a question here. How will we know if there is a YouTube video? So she was getting notices for fire weather videos a couple of days late this summer. Yeah, so that is a tough one. Oftentimes we won't necessarily advertise those, but if there is impactful weather happening, we do try and tweet about it and do a Facebook post as well. So just, I know I have a number of channels that I follow on YouTube, so if you just follow our channel, when you first log into YouTube, you'll see on the left-hand bar there'll be like little bubbles with how many unwatched videos there are for each of your channels. So I oftentimes use that for my personal use, and that would be one way to know if there's any new videos for an office. Other than that, maybe it's just a matter of kind of scrolling through and looking at what the most recent produced video is.